Okay, where the okay, set of all strings over the alphabet AB that contain at least two A's or exactly two B's. Okay, some of you have correctly solved it using DFA. As I saw, uh, some of the tutorials have, some of the students have solved it correctly using a DFA. But let's see how we can solve it using an easier way, solving using an NFA actually. So exactly two, at least two A's and exactly two B's, or exactly two B's, or both. Okay. So if there is a third B after this, then it goes nowhere. Okay, so this does not mean that it remains in the accepted state. See, okay, so if your string is, let's say, BBA, then B from Q0 it will go to Q1, from Q1 it will go to Q2, and for this A it will remain in Q2. But if it is, let's say, BBAB, then it will not remain in Q2. In an NFA, if there is no transition from this, it means that it remains, it goes to the dead state that we had drawn. It goes to the dead state. So if there is no transition from a state on a given input, does not mean that it is accepted. Okay. So this is for exactly two B's. Now for at least two A's, okay. Okay, now for B, okay, so if I get a B over here, should move to this state. Okay, wait. Yeah, this will be your okay. This can be one of the NFS. Basically, there is no unique solution. Like most of you had drawn up an elaborate DFA with many states, which is also correct. Any counter example that you can think of in this case?
Sir, 3B and 3A.
BB and 3A.
3Bs and 3As.
Okay, 3Bs and 3As. And Yash has said BB, ABA. Then AAB, AA, BA. Okay, let's try for this. So the condition is exactly uh, exactly two Bs or at least two As or both. Okay, so in this case, on first B, it will go from Q0 to Q1. Second B, Q1 to Q2. On third B, it cannot go anywhere from there. Okay, okay, let's make it a DFA. Okay, let's add this transition. Let's add this transition then. This will not work this way.
So can we add an epsilon after Q0 to Q3?
What will that help? How will that help?
So like if from Q0 to Q3, it goes to Q3 after epsilon, and then from if we can create a loop for B as well, na? Because here the lower loop is not counting if the string starts for B. So then it will count for if the string starts from B as well.
Okay, yes. Okay, so now in this case, BBB. So yeah, it can take an epsilon transition. BBB, AA, and then A. Okay, then second one, BB, ABA, BB, A, B, A. A, B, third one, A, that is, if you can see my mouse pointer, I hope. So it stays in Q0 for A. Then on B, it will go to Q1. Then again A here, and then on B, it will transition to Q2 accepted. What would be the regular expression for this?
Sir, how the second one will be accepted?
Okay, so basically, the upper branch is when there are exactly two B's, and the lower branch is when there are at least two A's. Okay, so in the second case, we have at least two A's. So we'll go here. Like, so for the first one, like, will not go from Q0 to Q1 on the first P. We'll use this epsilon transition and go to state Q3. In the state Q3, uh, we'll loop here for B and B. Then on A, we'll transition to Q4. Then we'll loop at Q4 for this B, and then we on this A, we'll move on to Q5, which is accepted. This so this will accept the first string input
Sir, why do we have a loop on Q0?
because otherwise, like, if the string consists of all A's, then actually it is not required. Yes, it can be removed, but it's fine. Okay, so in which case, what was in my mind in this case is,
So if the string starts with A,
yes, but it can also take this epsilon transition and go to Q3. So this is like an equivalent thing. Yeah, correct, Piyushi. So string starts with A and it has to take this upper branch. It cannot take this lower branch. Then it will have to. Then this will be required. Okay, so any number of A's then followed by exactly two B's. So in the strings which have exactly two B's, and we have to take this upper branch. So in that case, if it starts with A, then it will be a problem if this self loop on A is not there at Q0. Okay. Next doubt was, so Hemant, which string were you talking about?
No, sir, it was previously not
Okay.
accepting that first string
Yes,
BBAB.
yes. Okay. Next doubt is tutorial 4, question 4.
Hello, sir.
Yes.
What will be the regular expression for this?
Okay. Wait a minute. Tutorial 4. Okay, this question is okay. Tutorial 4, question 4. Okay. Yeah. Okay. Then tutorial 5, question 1D was something different. Okay, this is the regular. Okay, fine. Okay. Yes. Regular expression. Yes. Okay. Regular expression for this will be. mm, for the first part, at least two. Let's say at least two A's that we have. Okay, this is at least two A's, and then followed by no, I cannot directly put. Okay, I can use plus over here. I cannot directly put a star here because then it can be zero occurrences as well, which we don't want. Epsilon is not there in this language because it has at least. So this is one part, and for the second part, exactly two B's. Even here, that part was missing. Now, what to do in case we have both, which should be accepted? Does this, okay, let's try these on. So, will this language accept the strings that have at least two A's as well as exactly two B's? It will accept. This is the regular expression. Any questions on this? Is this regular expression fine?
Sir,
Yes.
sir, in the first half, B star at the end is not necessary because the B star at the start can compensate for it in the next iteration. Actually, no, sir, because then,
Yes.
yeah, because if 2A is there, then
Yes. Yes.
I got it, sir. Okay.
Okay.
Sir, what if the string is 4 A's?
Just four A's.
Yes,
So in this case, this part will be taken.
but there are only 2 A's, not there.
So we can have another iteration. Like iteration is not the right word, but yeah, iteration, yes. So these stars will all be zero. Like we'll take this part of the regular expression. These stars, that is B star here, zero occurrences of B, zero occurrences of B, zero occurrences of B, A, and this plus means at least once, right? So at least once, and it can be many times, but at least once. So we'll take this bracket two times.
Okay.
Okay, then what is the next question?
So,
Yes.
what if the string is A A B B B, 2 times A and 3 times B?
Okay. So in that case again, 2 times A and 3 times B. Yeah. Again, this part will be used. So, okay, I'll show it like this. So zero occurrences for this, zero occurrences for this, 2 times A, and this will be 3 times. and this will be 1. This will be 1. Okay. Okay. Questions. Lot of questions. A star B, A star B, A star. Acha, you had your own. Okay. B B A star. Okay, these are all your suggestions for the regular expression. Okay, so let's see first. A star B, A star B, A star, which I also have in my thing. Then B star A, B star A. Instead of B star, you have written A plus B star. Then again A, and then B star. Okay, is this regular expression fine? Yes, what I've written. Mm, yes, okay. Then, acha, Hemant, BB A star will not work. Then B star A, B star A. Okay, so I think this is fine. Plus, can the regular expression be B star A, B star A, B star, then A plus B star, and then A star B, A star B, A star. The problem in this will be there can be a case where like it it can be actually, instead of writing this plus over here, you can have this separate thing and write A plus B star.
Sir,
Yes.
sir, in your regular expression, will it accept AABA?
AABA.
Yes, sir.
At least 2 A's, that condition is satisfied. Hmm. A B A. Yes, you're okay. I can take something from your suggestion, Zainab. Is that this bracket can be changed? Correct. Instead of having B star, I can have A plus B star, then A, then A plus B star, because it is at least, then A, and then again A plus B star instead of this bracket. And then this bracket will remain as it is. Okay, or this bracket will remain as it is. This bracket should be changed. So you're saying about AABA. Uh, it can be accommodated here, right? So one occurrence of this, instead of amongst A and B, we'll take A, one A from here, then this A will come here, and then one occurrence of this. Okay, this is one, and amongst A and B, we'll take B, and finally A, and this will be 0. So yeah, good suggestion. Pratik, B star A. Yes, who is speaking? Speak.
Sir, will my suggestion also work if I write that?
Okay, where was yours? B star A, B star A, B star, and then A plus B star. right? So
Yes, sir.
yes, that will also work. Work. Yes. So this bracket as it is. Okay. B star A, B star A, B star followed by A plus B star. Okay, this will work. Okay, I was here. Pratik has suggested B star A, B star A, and then A plus B star directly. I think this is the most general thing, the one suggested by Zainab, I think. Yeah, so this is the most general thing. A plus B, this is also logically, like, it can be logically understood in the sense that, see, my logic was here, like, the first brace is for at least two A's and second is for exactly two B's. So at least two A's means at least two A's, and then amongst this A plus B star, A plus B star, A plus B star, there can be other A's coming from here as well. So I eliminated, so you eliminated this bracket raised to plus thing. Bhavika suggested B star A, B star A plus B star plus A star B, A star B, A star. Yeah, so okay. We can also add A star after B star. No, after, before. Yes, lot of things can be. Yes, it is also possible to accommodate multiple A's, but then it will be like there should be A star somewhere before as well. Maybe, right? Mm. If I just add A star here in this original one, it can start with a B, it can start with A, all A's will be acceptable. Yes, it can also work. Yes, yes. B star A, B star A, B star, A star. Yes. So as you can see, whether it is finite automata, whether it is regular expression, there is no one correct answer as such. What else? So, yes, what is the next question? Next doubt? Anything? Epsilon NFA. Okay. Exactly what part of epsilon NFA? Can you unmute and ask?
Sir, actually, I was not there during Epsilon NFA, so
Okay. And Mateen has asked also for NFA. Epsilon NFA is nothing but NFA in which there can be epsilon transitions. Epsilon transitions means, like, the example that I had given was of recognizing decimal numbers. So basically, when there is an epsilon transition, the states are equivalent. So what I'll do is I'll show you an example of an epsilon NFA, and I'll convert that NFA into a DFA. Okay, a smaller example.
Excuse me, sir.
Yes.
So in the diagram at Q3, for A input, it's self loop also, and it's going to Q4 also. So there
Yes.
can be any number of for same input, any number of transition.
It is an NFA, na? That's why.
Okay.
NFA can have multiple transitions on the same input symbol.
There can be any number, so means.
Yes.
Okay.
Okay, so I'll give you an example of a small NFA and then how it can be converted into DFA. So everything, so because that example was a big one that I took on in the lecture that day. So let's say I have an NFA. Okay. There was no question in the tutorial on converting NFA to DFA, but it was covered in the lecture. This is, let's say on A it goes to Q1, then there is an epsilon transition, Q2, okay, let's say this is the NFA that we have. This is an epsilon NFA that we have. Okay, so as you can see, not only there can be multiple transitions from a state to another state. So on a given input symbol, let's say if I take the example of this NFA, on A, we can move from the state Q3 to Q4, or we can also stay in the state Q3 on the same input symbol A. So this is one feature. Another feature is, as you can see here, there can be no transition from a given state for a symbol. Like in this case, there is no transition from Q0 on the symbol B. There is no transition from the state Q1 on the symbol B, and there is no transition from state Q2 on the symbol A. So all these things are allowed in NFA. Additionally, in epsilon NFA, we also allow transitions on epsilon. Transition on epsilon means a state can spontaneously move to another state without any input. So Q1 can move to Q2 without any input symbol, which also means in fact that Q1 is in a way equivalent to Q2, or you can say, because Q1 can, as it is move to Q2, Q1 is like Q2. Okay, they are just equivalent in a way. Okay, so this is just for an example that I have given here. So let's try to convert this epsilon NFA to a TFA. Okay, so first is we'll find the epsilon closure of all the states. First step is finding epsilon closure. So in this case, epsilon closure of Q1 will be Q1, Q2. Okay, so Q1, Q2, because there is an epsilon transition from Q1 to Q2, therefore they are like equivalent. Then okay, so let's start from the beginning. So the first state is Q0. Q0, epsilon closure of Q0 is Q0. Okay, because there is no other epsilon transition. Epsilon closure of Q0 is Q0. Okay, so on the input A, Q0 moves to the state Q1. Okay, so first is to calculate epsilon closure. Epsilon closure of Q2 is nothing but Q2. So let it be as it is. Then on A, we move from Q0 to Q1, Q2. Okay. On B, there is no transition. So we introduce another state which is called as the dead state. Which is called as the dead state. So the NFA dies basically. If there is a B, this NFA means that the string must start with an A. If it starts with a B, it dies. Nothing further happens. It goes to the dead state. Impossible move. In other words, it's an impossible move. Okay. So okay, now from Q1, Q2, if it is in state Q1 and it reads an A, it can go to Q1. And from Q1, it makes an epsilon transition to Q2. So therefore, on the input A, the transition is again Q1, Q2. Okay. Then on input B, there is no transition for Q1, but there is an epsilon transition too. So if the input is B, we can also consider it as epsilon B, because epsilon can be added anywhere. It's empty. So consider this as, if there is, the input is B, consider this as epsilon B. So effectively, we'll move from Q1 to Q2 and from Q2 to Q0. So the transition will be Q0. Okay. And for Q2, we actually don't require to, because again, this will not be required as such. This will not be required. So let it be here. Q2 is in its own epsilon closure, but it's not required. We have covered all the possible transitions in this case. Okay, because again on A, the transition will be to Q1, Q2, and on B, the transition will be again to Q0. So in a way, it will be redundant. It will be just like the state Q1, Q2 that we have already built. So we can just ignore this state. So we'll have, effectively, we'll have three states. One is Q0, other one is Q1, Q2, and the third one is the dead state. Okay. So Q0 is the start state. On A, it moves to Q2, which you will have to enclose the circle to indicate a state. On B, it will go to the dead state. Q1, Q2, on A, there will be a self loop. And on B, it will move back to Q0. And when it reaches a dead state, whatever the further inputs are, it remains in the dead state. So this is the equivalent DFA. Okay, this example is clear. Yes. Okay. Now, okay, in tutorial 3 for first and second question, we have to take ASCII values for each character of the message. Yes. I think it was okay or something like that. So ASCII value for O and ASCII value for K. you'll have to encrypt separately. Yes, 111.107. Very tedious to be solved manually. Well, it will be taken care of in the exam. Like you'll have sufficient time for it. Maybe only one character will be given or something like that. We have to encrypt separately or combined. You'll have to encrypt O separately and then K separately, and
So can you solve it once?
which one?
Sir, the tutorial 3, question number 1 and 2.
Okay, it will be two. Okay, so it will take a lot of time if I solve it here right now.
Sir,
Uh,
only tell the procedure. I will
yes,
solve
yes,
it
yes.
on my own.
Yeah. So the first thing is you have a message, which is an integer. So you were given a choice to choose any. First of all, you have to choose n, the modulus. Wait, I'll open the question because I had mentioned a condition over there. The condition was basically that the modulus should be greater than the message. No, yeah, the modulus. Assume the Yes, I have just mentioned assume the appropriate primes and this. But if you remember the note that I had posted, I want those exact words. Yes, the message M cannot be greater than the modulus N. In case of RSA and L-Gamal crypto system, if your message is an ASCII character, your modulus must be at least 128 in RSA or 131 in L-Gamal because L-Gamal requires it to be a prime. And in RSA, it can be anything. Encrypt and decrypt the message unambiguously. So that is the first thing while choosing N. Uh, on a safer side, you can choose 131 because it will apply both to RSA as well as Elgamal crypto system. Let's say. Then, okay, steps.
Sir, we have to encrypt O and K separately.
Yes. Okay, I'll just
Okay.
revise the steps once. So the steps will be first we'll have to decide E based on so you have N. How will you get N? So for N you will require P and Q first. Okay, so choose any P and Q. I'll just outline the steps. M is given in the question. M is given in the question. Choose P and Q such that N is at least 128. At least 128 means choose something greater only. Like don't stick at 128. Choose something greater than 128. Okay, this is the next step. Choose P and Q. Then you will multiply P and Q. You will get N. Okay, this is a part of the same step actually. P into Q is N. Okay, then calculate phi of N, quotient function of N. because it is a product of P and Q. It is nothing but totient function of P into totient function of Q, and P and Q are primes. Choose primes P and Q. It's the important part. Choose the prime numbers P and Q such that their product is at least 128. Then calculate n. Then calculate totient function of n, which is totient function of P into Q. Then next step will be assume any value for E. Okay. Assume E. Assume E. Only restriction is GCD of E and totient function of n should be 1. Okay, so E and the totient function that you calculate here should not have any common factors. Okay, their GCD should be 1. You don't have to apply any procedure for this. Okay, you just select some E. Okay, any prime number. E is also a prime. Assume E is also a prime number. And when I say no common factors means that this phi of n should not be a multiple of E because E is a prime. So phi of n should not be a multiple of E to such a prime. Then next thing is you have to find D. Now this is the calculation that you'll have to perform. Calculate D. So D is nothing but E multiplicative inverse of E mod phi n. It is the multiplicative inverse. So which algorithm will you use for finding multiplicative inverse? Extended Euclidean, correct. So you'll calculate this using extended Euclidean algorithm. Then so we have the private key. Now what? Now we'll encrypt. Encryption using public key. Okay, so at this stage you have the public key. Public key is nothing but E and N, and private key is D and N. This is the private key. Okay, so encryption using the public key will be m raised to E mod n or mod phi n, mod n or mod phi n, mod n, perfect. Okay, so mod n. So this will be your ciphertext C. This will be your ciphertext C. Now you can say that this C, the ciphertext, has been received by the other party, and now the other party wants to. So if the question asks for decryption, decryption will require private key. Decryption will require private key, and the decryption will be such that m raised to e mod n, okay, which is c. The entire thing will be raised to t mod n. This is what we are doing is c raised to d mod n, which is equal to this, which is equal to m raised to ed mod n. You need not write mod n repeatedly, so you can write it in this way and use the congruence symbol. Okay, but we know that ed, okay, ed mod n is 1, therefore it gives us m mod n. This is the final step. These are the steps. So in our question, we have to calculate separate ciphertext for O and K. In the question that was given for the tutorial, because it was a tutorial, so I had given you in that way that you have to calculate it for O and K separately. You have to encrypt it, because this is how it happens actually. It's like a stream of characters. Encryption happens in either in a blocks. It is so. If we assume a stream cipher, the encryption takes place in a stream. So every character will be encrypted separately, and so not only ciphertext, you will ask for decryption as well in that, right? Uh, Also decrypt the message. Yes. Hello, hello. Am I audible? Yes. Okay. Okay. So I think your the last question was you can, okay. So you cannot concatenate the ASCII values for O and K. Okay. So 111107 will not be your message. Okay. Okay, now the steps for El Gamal crypto system. Okay. So for El Gamal crypto system, this was for RSA. So first you will have to choose a prime. Uh, choose a prime P. Then calculate only one. You just require one primitive root of P. One primitive root of P. Okay, and let it be G. So G is the primitive root of G is the primitive root mod P. G is the primitive root mod P. Then both the parties will have their secrets chosen. So Alice will select A such that it lies between 2 and P minus 2. And Alice will calculate her secret. I think I had used some different alphabet. Let's say H of A is G raised to A mod P. Now encryption will take place. In encryption, let's say Bob wants to send the message M. Bob wants to send M. So Bob will choose a B. Bob will select B such that B lies between 2 and P minus 2. Bob will calculate his secret, it is HB, which is G raised to B mod P. And then for encryption, Bob will do uh, the secret that he has received from Alice, that is HA raised to B multiplied by M mod P. That will be the ciphertext. Okay. Now this is sent to Alice. Now decryption. Decryption will be ciphertext multiplied by Bob's secret. Secret in the sense, okay, so this is like Diffie-Hellman exchange. So Alice calculates her HA, Bob calculates his HB, and they send it to each other. So Alice knows HB and Bob knows HA. Even though Alice does not know what is B and Bob does not know what is A. Okay. So for decryption, what Alice will do is ciphertext multiplied by the secret shared by Bob raised to minus A mod P. Okay, this will give you the message M. These are the steps for El-Gamal crypto system. And to actually perform these calculations, you will require the different theorems and results that we studied all along in the first module. Any questions on this? Any further questions? Okay, then I'll end this session here. Okay.